Welcome to Verizon Innovative Learning. Imagine, you are a site engineer responsible for all the happenings at a large, busy construction site. There are a lot of obstacles on this construction site. Your task today is to use a robot to get materials from one side of the construction site to the other, avoiding all the obstacles in the way. The robot that you will be using today is called the Ozobot Bit. This robot uses code, or a set of instructions that the computer within the robot can understand, that tells it which way to move. The Ozobot Bit is special because it's equipped with color sensors that can read color codes to determine the set of instructions that it will follow. You may be asking, what are color codes? Color codes are color sequences made of 2, 3, or 4 color dots in a row located directly on a path. For example, if you want the Ozobot to turn right, you would create a color code that reads blue, red, green. And just like that, the Ozobot turns right. The turn right code just demonstrated is an example of an Ozo code that the Ozobot can understand. Ozo codes are all of the color codes that the Ozobot can understand. There are Ozo codes for speed, direction, timer, special and cool moves, win and exit, and counters. These Ozo codes will be created using 4 markers provided. The colors used are red, green, blue, and black. These colors will be used to lay down code for the Ozobot to follow. Your code will be laid down on dot paper. Each dot is 5 millimeters apart, and the dots act as a great guide to help your path stay straight and have an appropriate width for the Ozobot to understand the code. Now that you know how to write the code to get your robot across the construction site, it's time to talk about criteria and constraints. Criteria refers to the rules or directions that must be followed. They are the requirements that must be met. Constraints refer to limitations or restrictions that can impact your decision-making. The criteria for today's task is that you must use at least 5 Ozo codes. These are to include at least 2 speed codes, 2 direction codes, and 1 special or cool moves code. You must also place 5 obstacle blocks apart from each other on the dot paper. The constraints for today's task have to do with space and turns. You are limited to the space provided by 1 sheet of dot paper, and your path will stay within the dots, meaning all turns will create a 90-degree angle. This means the turns will look like the corner of the letter L. You are going to use the engineering design process to guide your code design today. This is the step-by-step process that asks a question, explores possible answers to that question, creates models of what the answer might look like, evaluates the answer, and finally explains why that answer works. Let's break down each step of the process for your code design. For the ask step, the question today is, how can I design a coded path for my robot to safely deliver materials from one side of the construction site to the other, staying within the criteria and constraint set? Now it's time to explore and model a code design that will answer the question. You will use the Ozo codes to explore possible code designs and in turn, create a model that gets your robot safely across the construction site. After the model is created, it's time to evaluate whether or not the code design allows the robot to get across the construction site safely, meeting the criteria and constraints. After you've evaluated the model and found that it works, the final step in the design process is to explain how the design accomplishes the task. If you can do this, the code design is a success. Okay, engineers, now it's time to put on your hard hats and get to work on our code design. Good luck and happy coding!